right. Over the past couple of days, we've done quite a bit with the Pythagorean theorem. We looked at the Pythagorean theorem: a squared plus b squared equals c squared, and made sure that we knew how to break down and do factor trees if we needed to simplify our square root. Yesterday, we took a look at the converse of the Pythagorean theorem, which lets us know if a triangle is a right triangle, acute triangle, or obtuse triangle. The last little piece that we're going to do with the Pythagorean theorem is that we're going to use the Pythagorean theorem to help us find the length of a dotted segment. So we're looking at three-dimensional shapes, rectangular prisms or a cube, and we're going to find the hypotenuse, and that's kind of like air quotes around there, but we're going to find the length of the diagonal line from one corner to the next. From one corner to the next, and down here we'll do 3 examples from one corner to the next. So when we're doing these problems, we're going to have to do the Pythagorean theorem twice. So the easiest way I can explain it is that we're going to have to consider the base of the object as a two-dimensional shape, and we'll do the Pythagorean theorem with the base of the object. Then we got to consider the height, which makes it three-dimensional, which means we'll have to do the Pythagorean theorem again. So we'll do the Pythagorean theorem once with the base as a 2D figure. Then we'll have to make it three-dimensional, so we have to include the height. So let's get started. So the first one here, I have a rectangular prism, 8 inches by 6 inches by 7 inches, and we're trying to find the length of this dotted line segment. So the first thing we're going to do is do 8 squared plus 6 squared. So we're going to consider the base of the object first. So 8 squared plus 6 squared equals c squared. So we're doing two-dimensional first, a flat object. As always, these legs are interchangeable. If you want to do 6 squared plus 8 squared, same difference. We go through and work this out. 8 squared plus 6 squared, you simply can type that in Desmos. That's going to give me 100 equals c squared. From here, take the square root of both sides, and that gives me 10 equals c. Now, ordinarily, we would be finished, voila, Pythagorean theorem. But now we have a three-dimensional figure. So I need to include the fact that my height is 7 inches. So now we're going to do Pythagorean theorem with this number and this number. So we're going to include the answer that we just found, which was 10, and then this number over here. So let me see if I can squeeze that in right here. So now I'm going to do the second part of the problem over here. So now I'm doing Pythagorean theorem with 10 squared plus 7 squared equals c squared, which in this case, my c squared is going to be my final answer in this case. So again, calculator, mental math, we work this out. 10 squared plus 7 squared, add that together, I got 149 equals c squared. We take the square root of both sides. Square root of 149. You would do a factor tree and see if you can break 149 down, but you cannot break 149 down. So I'm going to leave it as the square root of 149. So again, we would need to do a factor tree, see if there's something times something to give me 149. But I cannot break this number down into pairs of the same number, so it stays 149. So my final answer as a square root will be 149. And as a decimal, we'll round to the nearest hundredth. I got 12 and 21 hundredths. So this is my answer. So as a square root, this is my answer. And then as a decimal, this is my answer. And that is the first example. So we're going to go through, we'll do a couple of more, the same pattern, same premises here. We're going to do Pythagorean theorem with the base because that's going to make it the flat object, two-dimensional that we're used to working with. Then we're going to make it 3D by adding whatever the height is. So, and we're looking for this line segment here. So this line segment here is the square root of 149, and as a decimal is 12 and 21 hundredths. Okay, next, we're going to do our base. So my base here is 10 and 8. So I'm going to do 10 squared plus 8 squared equals c squared. Mental math calculator, 10 squared plus 8 squared gives me 164. Take the square root of both sides. That gives me the square root of 164 equals c. Now, I do not want to break this down just yet. because I got to use it again. So I'm just going to go ahead and carry this into the second Pythagorean theorem that I have to do. And then at the very end, we'll do our factor tree and simplify if necessary. So now I need to take the square root of 164, and I need to do Pythagorean theorem with the square root of 164 and my height so that I can make it a three-dimensional object. So now I'm doing the square root of 164 squared plus 12 squared equals c squared. Now, if I compare this to example 1, I'm doing the same thing. I took my answer, which was 10, and I used my height to do Pythagorean theorem a second time. I take my answer from the first part, and I use my height to do Pythagorean theorem a second time. Of course, the only difference is for the first example we did, 10 didn't have the square root anymore. It went away. This one, I still have the square root, but that's okay. I still can go through and figure that out. In a calculator, or even better than that, in Desmos, if you type in the square root of 164 squared, it's going to give you 164, which is fine. That is the correct answer. So let me go through that again. When you put the square root of 164 and you square it, square root and squaring cancel out. So we're left with 164 plus 12 squared equals c squared. So this section right here, square root of 164 times the square root of 164, it'll always cancel out, and I'm left with 164. Now I could do 164 plus 12 squared. I can type that in the calculator. I got 308 equals c squared. So 164 plus 12 squared. That gave me 308 equals c squared. Take the square root. And I got that the square root of 308 is equal to c. And of course, we got to go through and we got to do a factor tree for 308. Good morning, Iris. Please stand and join me in the Pledge of Allegiance. All right, we're going to hear the announcements for just a minute, so bear with me. To the flag of the United States of America.